All right, I forgot my stylus, so I'm not going to do a show me. I'll try something via YouTube. There was a Theorem 4-1 in the textbook that states if two angles of one triangle are congruent to two angles of another triangle, then the third set of angles are congruent. Well, we can justify this by saying the measure of angle B plus the measure of angle C plus the measure of angle D is equal to 180. Measure of angle A plus the measure of angle P plus the measure of angle L is equal to 180. And that essentially because of triangle sum. The interior angles of a triangle have sum 180 degrees. We know that angle B is congruent to angle A. We know, therefore, the measure of angle B equals the measure of angle A. We know that angle C is congruent to angle P. Hence, the measure of angle C equals the measure of angle P. So let's do a little bit of substitution. I could set the measure of angle B plus the measure of angle C plus the measure of angle D equal to the measure of angle A plus the measure of angle P plus the measure of angle L, because they both equal 180. Well, if the measure of angle B equals the measure of angle A, the measure of angle C equals the measure of angle P, I could subtract the measure of angle B from the left side, the measure of angle A from the right side. I could subtract the measure of angle C from the left side, the measure of angle P from the right side. Therefore, I could then yield that the measure of angle D is equal to the measure of angle L, due to just subtraction of equal quantities from both sides of the equation. Hence, that's demonstrating the third set of angles are congruent in this theorem. So we have two examples in the note sheet. Let's mark what's been given. We're given, you can't see that too well, so let's try that. We're given segment AD is congruent to segment AB. We're given segment DC is congruent to segment BC. We're given angle D is congruent to angle B. We're given that angle BAC is congruent to angle DAC. And we're finally given that, okay, those are the things we're given. Now we have to prove the triangles are congruent. We have not been given any other information. And we, unfortunately, live in a world in which we must show that three sides of one triangle are congruent to three sides of another, three angles of one triangle are congruent to three angles of another, before we can say the triangles are congruent. Well, but we know that segment AC is congruent, sorry about that, angle AC is congruent to angle AC, and that's due to a property from our past that I promised you we would use, and I promised that you might not understand why we would ever want to use it, but today is the day. It's the reflexive property. So here we have the reflexive property. Then I could also say that the angle DCA is congruent to angle BCA And that is the theorem for 1. If two angles, angles of a triangle are congruent to two angles of another triangle, then the third set of angles are congruent, or theorem with 4-1. So right there, I've just proved that I have some triangles congruent, or I'm about to, because I could say triángulo, if we were speaking Spanish. ADC is congruent to triangle ABC, or I'm sorry, I have to, and that's because if three sides of one triangle are congruent to three sides of another triangle, and three angles of one triangle are congruent to three angles of another triangle, the triangles are congruent. Now, I'll get all of that. Well, maybe I won't get all of it over to that one side. I'm not going to be able to do it. But that explains it. Then my last example is here. I just have to write a triangle congruence. And I just need to make sure that my congruent sides line up, my congruent angles line up. So here I'd say triangle BDC is congruent to triangle, well, B corresponds with X, right? D corresponds with Z, and C corresponds with Y. That's all the news that's fit to print. I really hope this helps. Thank you.